lesson, we talk about constructors, constructor of the class. Now we talk a little bit more about constructors and about destructors and about the operations overloading. We consider it on very simple example of a complex number, but the complex number with a name. Of course, usually complex number has only two data members, real and imaginary part, like here, real and image. Only these two values is there. Sorry, the data members. But suppose that I want to store here the name of the variable. This name I want to store in the dynamic array of the type char, because the strings in C and C++ are considered as an array of characters. And here name is just the pointer to the first character. Well, let's do it. Let me put here one more data member, the name of the variable. First, what I should do, I should allocate a memory for this name in constructor. Maybe I don't remember. Is it written here? No, it's not written, but okay. First, for this name, I should allocate the memory. Suppose that the number of characters in name is fixed. Suppose that it is 10. In this case, in any constructor, I should write the following line. Name equals to new r and the size of the array. The constructor is executed when the class is created. And here the name should be empty. To do it, I can assign to the first symbol a special symbol end of line. /0 corresponds to the end of the string, and it means that the name will be empty. What I should do in copy constructor? Copy constructor gets as a parameter constant reference to the class, and here I just assign the data members. Real equals to real, image equals to image. What happens if I write here is the name? This assignment from the point of view of compiler is correct, but it's not correct. It's not correct from the problem statement. Why? If I just assign two pointers, name from the from object A and name from object B, these two pointers will point to the same string B, the same memory. Here I declare two variables of the type named complex, B and A that equals to B. And if I write in a copy constructor just this assignment, it will be wrong, because two objects will refer to the same memory. How this problem can be corrected? So this situation is not correct. And this situation on the right picture is correct. Correct. Correct copy constructor should create a new string, new array of characters, and reassign all of the characters from this array to this one. Well, in general, I can say that if the class includes a pointer as a member field, it is necessary to provide a copy constructor. You must provide a copy constructor. Without it, your class will be wrong. So if your class includes a pointer of any type, this type may be char, double, int, any type. We should take care about this pointer in a copy constructor. What should we do? We should reassign real and imaginary parts, and let me, here it's written more complex variant of copy constructor. Let me write more simple. I'll do it right now in Visual Studio. More simple because here we have only 10, the fixed number of the fixed number of characters in this line. What should we do? We should assign a new memory for the name, new char 10. And after that, we should copy all the characters from the field name from object T to this object. If we have this array of 10 characters, it can be done just with using for loop for I equals to 0, I smaller than 10, I plus plus is name I equals to T point name I. again, this line, I allocate the memory for the variable name. And this loop, I copy all of the symbols from the name of the object T to the name of this object. After such operations, copy constructor will be correct. Well, some brief overview of constructors. Constructor is a special member function that is called when the object is created. There are several types of the constructor. Default constructor, constructor initializer, copy constructor, and so on. To avoid the errors, it's better to write constructors by yourself, not relying on the compiler. Sometimes, when you didn't write any constructor, compiler creates this constructor automatically by default. But this default constructor is not very good. Maybe it initializes the values, the data fields with undefined values and so on. So it's better to write your own constructors by yourself. Well, any questions about constructors? If no, let's move to the next slide. And let's talk about destructor. Destructor is a special member function that deletes, that is called when the object is deleted from the memory. How to create the destructor? The name of the destructor is a class, is the name of the class. Special symbol, twiddle, before the name of the class. So if the class has a name example, the destructor must have a name example with twiddle. Destructor doesn't have any parameters. So the list of parameter is empty. The destructor is created by compiler automatically if we do not provide destructor. It means that if you don't write destructor in your class, this simple destructor will be created automatically. The destructor is called automatically for statically created object. It means that if you create an object inside some block of your program, the compiler automatically call the destructor when you finish the block. Well, It means that if you create an object in the main function here, the destructor for the objects B and C will be called when you finish the program, because these objects are created inside this block, and the destructor will be called when the block is over. And when you create an object dynamically using operator new, the destructor will called when you call the delete operator for your dynamically created object. In this example in Visual Studio, suppose that I create the object PA. Let me do it here. Complex pointer PA that equals to new not class, new complex and the parameters of constructor, for example, 0 and 2. It means that I create an object complex dynamically. The pointer PA points to this object. And when I call new, constructor will be called. And when I call delete, destructor will be called. Well, it's the same example that I already show you in Visual Studio. So if you create an object A of some class statically inside a block, here, when the block is finished, the destructor is called. When you create an object dynamically, destructor will be called when you call the delete operation. Why we need to provide a destructor? To avoid memory leaks. For example, in our case, the pointer name points to the name of the particular variable of the type complex. Where we allocate the memory for the name, we allocate it in the constructor of the class. Here, we allocate a new memory. And also these two lines, it must be written in the default constructor too. Let's do it. Let's do it in default constructor. But when this memory is deleted, this memory must be deleted manually in the destructor. How we can do it? We should write the destructor and only one operation, delete name. When we call delete name, the memory that was allocated for the field name will be released. If we forget to call this delete, or if we don't write the destructor for the class complex, in this case, this memory still be considered as a used memory, not free. This situation is called a memory leak. And if you create a lot of complex variables and after that you delete it, the total amount of leaked memory can be very large. Well, let's write the destructor in the class. Only one difference, because our class is called complex, not named complex, just complex. And the destructor in our case consists of only one line. Delete name. Well, to see when the destructor is actually called, let's do the following thing. Let's write here output statement. Let's output here the line the destructor is called, and let's output here real and image. And let's write handle and a space between real and image. Okay, something like this. Let's compile this program. Oops, some mistake. Oh, okay, cout is not defined. Or let's to fix this mistake, let's move the implementation of the destructor to the CPP file. How we can do it? Here in H file, we write only prototype of the destructor, and the implementation of the destructor we write in CPP file. Complex is the name of the class. After that, the name of the function. The name of the function is twiddle complex. It's a destructor, and the implementation of the destructor. From this point of view, the destructor is just a function. Here, it's a prototype of the function, and here the implementation. Okay. Well, let's look to our class, to our program. How many objects are there? 1, 2, 3, 4, 5, and 6. We have here 6 objects. So we should see on the screen 6 messages from the destructor, because the destructor will be called for each of these objects. What message we will see first? we will see first the message from the object PA. So we will see on the screen 02. This object will be deleted because this object is created dynamically and we delete it here. And after that, at this point, the destructors for the objects A, B, C, and Z will be called. Let's check. Let's run this program. Yes, and we will see 6 messages on the screen. And the first message is from the object PA. Of course, I include the output message in the destructor only to illustrate when the destructor is called. Let's remove this line. Actually, the destructor should contain only one statement: delete and name. Do you have any questions about destructors? No questions. Okay. And the next topic that we consider is operators overloading. But first, let's come back to the previous lecture when we consider the addition, 2 operations of addition, add and append. I already implemented in Visual Studio. Let's look to these operations. Add. This operation adds 2 complex number. This number and the number that is a parameter of this method. And the operation append adds the value of the parameter to their current number. Of course, here it's better to write here a constant reference. Let's fix this mistake. Let's fix it. And here in the function append, also let me write constant reference. Well, what is the purpose of what is the result of the function add? It works as follows. We create the new variable with the name result, and the real part of the result equals to re plus c.re. Imaginary part equals to im plus c.im. And we return the result to the calling function. The function append works as follows. We add the real part of the number c to real part of this number. Actually, this function can be written as this.re plus equals to c.re. and this arrow im plus equals to C point im. How we can use these operations? Here in the main program, I can write something like this: a point add, a point add, for example, z. In this case, the complex number z will be added to a, and we see the final result on the screen. Sorry, wait a minute. It's or, of course, not add. I want to call append. I want to call append. In this case, z will be added to a, and the value of a will be changed. And we see it on the screen. Yes, the value of a will be changed. The value of z will be the same. This is how append works. And add. Let's assign b. B equals to a add z. And let's output the value of the variable b. When we call the operation like this, the values of a and z still be the same. The value of b will be changed. Well, some problems, I don't know why, or I see, I understand why. Let me, for simplicity, remove this comment, this field name. The const. Oh, let it be name. Okay, with name. It's okay. Well, the function add actually works as addition, and this line corresponds to the operation b equals to a plus z. And C++ allows us to overload the standard operations for user-defined data types for the classes. And it can be done very, very simple. As far as the function add works exactly the same as addition, we can just give another name to the function add. We can use a special name to overload their standard plus. Let's switch to the definition of the class. And write one more function with a special name. This special name consists of the keyword operator and the sign of the operator. Let me repeat again that this function is just a function with the name operator plus. Here, this function has a name add. This function has a name operator plus. I must define this function. I must write a definition. Let's copy the body of the function add, and let's write here operator plus. Now I redefine plus for the class complex. And after that, I can write in my program plus for two objects of type complex. And I can apply this operation as usual numbers. Not b equals to a add z, but b equals to a plus z. Yes. I overload the operator plus. And the same situation is true for any other operator. For example, the function append, if I write something like a append z, function actually works like a plus equals z. I add the value of the variable z to the variable a, and I can overload this operator plus equals. I can copy the header of the function append. I can give here another name, operator plus equals, and after that can write one more operator, plus equals, and after that it will be correct. Moreover, I can redefine the assignment operator. Do it. I can redefine assignment operator. Operator equals. What should I do in this case? I should write a new operator for the class complex operator equals. Here, new value of this re will be c.re, new value of im will be c point im, but we remember that every object has a name now, and here I must delete the previous name and copy the new name. In my example, the size of the name is the same. That's why I know it's not need to reallocate the memory, because all of the classes have the same memory, the same size of the memory, 10. And I can just copy their name from the object C to the name of this object. Well, let's check. Let's run this program, and we see that the program becomes correct. In C++, I can redefine any operator. There are only 4 operators that cannot be redefined. As I remember, these operators are parenthesis, point, arrow, and 4 dots. All other operations, all other operators can be redefined. Yes, it's working. And on the same way, I can define any other operators: minus, minus plus, multiply, the operator star, star, star equals, and so on. If I don't define these operators, and if I write b equals to a minus z, compiler returns the mistake. It will be an error, because I don't define the operator minus. Minus must be defined. When I define, as I define plus. And again, pay your attention that this line responds to the function add z. Operator plus is a function. It means that I can write, and it will be correct from the point of view of syntaxis, this rather strange construction. B equals to a point operator plus z. It means that I call operator plus for the object A, and I pass as a parameter the object z. This line will be correct. I can compile my program, and compiler tells me succeeded. But of course, it seems very strange to write these lines, such lines in the program. Of course, it's better to write a plus z. Okay. Do you have any questions about operators? Please, any questions? No questions. Well, as far as now only 4 students are here, I think we can finish. We can finish our lecture. Later this day, I will send you the presentation and I will send you the link to the video file of the lecture.
Okay, Professor.
Well, do you have any questions?
No, thank you.
Okay, I stop